Hey grade 12s, this is JP. I'm going to take you through the solutions to that functions, inverse functions worksheet. In the first one, so you've been given the straight line f of x is equal to 5x minus 3. You're asked to reflect about the line y is equal to x. That means you're going to swap x and y and solve for y, right? So you add 3 on both sides and you just divide every single term by 5. And then it looks a bit neater if you just write a fifth x rather than x over 5, fifth x plus 3 over 5. Cool. Question 2 there. So you've been given a parabola, 5x squared, reflect about the line y is equal to x. That means you're going to go from y is equal to 5x squared to x is equal to 5y squared. And again, you're going to solve for y. Divide both sides by 5, and then square root both sides. Remember the plus or minus. Together, this is not a function, remember, but one part of that will be a function. We're going to elaborate on that later. So there's that inverse equation. Question 3 there, you've been given y is equal to 3 to the power of x. Determine the equation of f of x is reflected about the x-axis. What happens if you reflect about the x-axis again? Reflect about the x-axis, your x value stays the same, but your y value is multiplied by minus 1. So you're going to multiply your y value by minus 1 and just solve for a positive y. You follow? Make y the subject of the equation, so you divide both sides by minus 1. And you get minus 3 to the power of x. Question B, reflect that same equation about the line y, the x-axis, reflected about the y-axis. What happens if you reflect about the y-axis? Your x value now is multiplied by minus 1. Your y value stays exactly the same. So y is equal to 3 to the power of x was the original equation. If you multiply the x value by minus 1, you get y is equal to minus 3 to the you get y is equal to 3 to the power of minus x. Question C. Determine the equation of f of x is reflected by the line y is equal to x. So y reflected by the line y is equal to x, so that's we're going to do inverse. So you've got y is equal to 3 to the power of x, that becomes then x is equal to 3 to the power of y, or y is your the one you want, your subject of the equation, but it's an exponent. What do you do? Log. The base is 3, the number is x, the exponent is y, right? So that and that's the same. Why do we prefer to write it in log form? Is because then y is the subject of the equation. It's y is equal to blah, blah, blah. Okay, and that just looks a bit sexy. Question 4. So if f of x is equal to 2 over x minus 3 plus by 4, find the inverse. Again, inverse reflected by the line y is equal to x. So what's going to happen here is, first of all, let's write it in terms of y. Then we're going to swap x and y, right? Reflected by the line y is equal to x. And now we want to make y the subject of the equation. So minus 4 on both sides first. Multiply by y minus 3 on both sides. Do you follow? So that's x minus 4 after you've minus 4. Multiply by y minus 4, or y minus 3 on both sides. Goodness. And then you're going to divide by x minus 4 on both sides, right? So then you're going to get 2 over x minus 4 is equal to y minus 3. And add 3 on both sides. So you get y is equal to 2 over x minus 4 plus by 3. It's a beautiful thing, this, to reflect the hyperbola in its natural habitat about the line y is equal to x. Is extraordinary. Why? So, good question. So in this, originally, p was equal to 3. Remember, it's y is equal to a over x minus p plus by q. And q was equal to 4. That means the one asymptote was at 3. And then you've got y is equal to 4. What happens if you reflect those lines about the line y is equal to x? That just means that the line y is equal to 4 now is going to become x is equal to 4. And then the line x is equal to 3 is now going to become y is equal to 4. How beautiful is that, eh? So, oh man. So, yeah, so do you see what happened? The 4 and the 3, and the 3 and the 4. Cha-cha-cha. Question 5, you've been given a log function, log base 4x. Oh, this is enough to scare you, eh? Sure. So, first of all, just remember this is just y is equal to that. So the first two questions are straightforward. Leave it in terms of y. You don't need to write it in exponential form. So if you reflect about the x-axis again, x value stays the same, but y value is multiplied by minus 1. So it becomes minus y is equal to log base 4x. divide both terms by minus 1, and you get y is equal to minus log 4x. To determine the equation of fx reflects about the y-axis, what happens if you reflect about the y-axis again? Xy becomes minus xy, right? The x values is multiplied by minus 1, y value stays the same. So that will mean that y is equal to log 4x will become y is equal to log 4 minus x. To determine the equation of the inverse of f of x is equal to log 4x. If you're going to find the inverse, rather it's best to write it in exponential form. So y is equal to log 4x, that becomes 4 to the y is equal to x. Those two things are exactly the same, right? So the one's just in log form and the other one in exponential form. Now, if you find the inverse, you're going to swap x and y, right? 4 to the x is equal to y, and now, yeah, y is alone. So therefore, the inverse is 4 to the power of x. Question 6. Determine the inverse of 2 to the power of x minus 1 plus by 3. What's happening here? So first thing you're going to do is you're going to swap x and y, right? Reflects about the line y is equal to x. So x is equal to 2 to the y minus 1 plus by 3. Right, and then you want to get y alone, so minus 3 on both sides. And y is the one you want. It's an exponent. What do you do? Who do you call? You call logarithms. So base of 2, number x minus 3 is equal to y minus 1. Isn't that just too beautiful? So, and then you just want to solve for y, make y the subject. So y is then equal to log base 2x minus 3 plus 1. And that's just in a sexier form. Question 7, f of x is equal to minus a half x minus 3 all squared plus by 4. That's a negative parabola, right? Turning point at 3 and 4. What happens to it if you reflect about the x-axis again? X-axis, the x value stays the same. Y value is multiplied by minus 1. So bang, bang, chicka, bang, bang. Multiply the y by minus 1 is equal to minus a half x minus 3 all squared plus by 4. You want to get a positive y. How do you do that? How do you do that? You divide every single term by minus 1. Or if you feel frisky, you multiply every single term by minus 1. So, B, determine the equation of f of x is reflected about the y-axis. What happens if it reflects about the y-axis again? Good question. That means the x value is multiplied by minus 1, but the y value stays the same. So again, x value is multiplied by minus 1. Do you see that? Okay, and then just remember there's a different way to write this. You can take out minus 1 as a common factor there. Take minus 1 out, so it becomes x plus by 3. And if you square all of that, oh, there's a bracket missing. Oh, bracket. So, there we go. So if you square that part there, that you're just going to get x plus by 3 all square plus by 4. Okay, question C then. Determine the inverse of that baby. So here's our question. Y is equal to minus a half x minus 3 all square plus by 4. So if I find the inverse, swap x and y, just solve y. Now how do I do that? Minus 4 on both sides. You want to get rid of the minus a half, so it's multiplied by minus 2 on both sides. Okay, how do you get rid of the square? You square root on both sides, remember the plus or minus sign. And lastly, you're going to add 3 on both sides. And then you get that baby. Question 8, determine the equation of the inverse of f of x is equal to log base a quarter x. Okay, base is a quarter. So first write in exponential form, quarter to the power of y is equal to x. Those two things are exactly the same. Now if I'm going to reflect about the line y is equal to x, you're going to swap x and y, and you solve for y, and y is then equal to a quarter to the power of x. There we go. Okay, just another way to write a quarter to the power of x. Quarter is 2 to the power of minus 2, right? So it's 2 to the power of minus 2 to the power of x. That becomes 2 to the power of minus 2x. So just take note of that. Next, I ask you to reflect some beautiful graphs about the line y is equal to x. So the first one, then all of these, I don't know, colorblind, the blue, greenish, I don't know what the color is you're going to reflect, that's the original function, you're going to reflect about the line y is equal to x. Okay, so here we go. So there's the y is equal to x cube. Oh, beautiful. Remember that's a cubic function where the stationary point is also the point of inflection. And so what happens is all the points where a graph and the line y is equal to x meets will stay those points, right? Good. And then what will happen? Do you see what happens here? So you're reflecting all those points about the line y is equal to x. So you can just do it segment by segment. It's best just to look at the coordinates. So like that is like 0.6 and 0.2, minus 0.6 and minus 0.2. So that is going to become 0.2 and minus 0.2 and minus 0.6. Do you follow? So all those little points you just reflect. So it's just an indication how it looks like. And in other words, the cubic function looked like this initially, and now it's looking like that. It kind of looked like it got just rotated 90 degrees, right? Is it? Think about it. Next up, we've got a cubic there. Can't remember the equation of this, but we've got two x-intercepts. We've got one turning point on the x-axis, and then we've got a stationary point, y-intercept. A lot going on here. Okay, so you just look at all those points. X-intercept will become now y-intercept. Minus 2, 0 is going to become 0 minus 2. Minus 1, 4 is going to become 4 minus 1. 0, 2 is going to become 2, 0. 1, 0 is going to become 0, 1. And whatever that point is. And then 2, 4 is going to become 4 and 2, right? 4 and 2 right there. I would circle the stationary points. That's just, it makes it easier. So you know this dude, minus 1, 4 is going to become 4 minus 1. So there's that one. And then 0, the other stationary point is at 1, 0. It's going to become going to become 0, 1. And then, so if you just look at all those points that you just, I mean, that's not bad, right? And then just remember there's the stationary point. So that's the local maximum. So that will be the local maximum there. So there's the local maximum. There's the local minimum, right? That one. And then it goes up again. Okay, yes, this graph, it was a piecewise function that's being asked to reflect about the line y is equal to x. So there's this point minus 5 minus 4, so that becomes minus 4 minus 5. There's, so that's the point. There's a point here minus 3 minus 2, so that's going to become minus 2 minus 3. So that turning point to there is going to become there. And then this point here, minus 1, 4, is going to become minus 4, 1. So this parabola here, right, if it reflects about the line y is equal to x, that's going to look like that. Okay, so that's, I think that's one way to just do it. You do it in those different parts. So we're here now, right? So minus 1, minus 4, okay, there's a straight line. So minus 1 minus 4, we say it becomes minus 4 minus 1, and that's a straight line up to 2 minus 4. So that, of course, will become minus 4, 2. 2 minus 4 will become minus 4, 2. Minus 4, 2 there. So those two connect with a straight line. There's that. Okay, and then we're going to, it passes through 3, 0, so that's 0, 3, and then it's on the line y is equal to x. So there's that part. And then that's the reflection about the line y is equal to x. Next up is just the graph in its inverse. So there's y is equal to 3x plus by 5. What happens to it is if you just look at those points, there's the y-intercept. So the y-intercept becomes the x-intercept. That point stays there. And so the x-intercept becomes the y-intercept, remember. And yeah, that's not too bad, right? Let's look at the next one. Question 2 there. So we've got f of x is equal to x minus 3 all square minus 4. So that's our, there's our original function. So the turning points, the x-intercepts, right, is going to go there. Turning point, that's going to go there. 3 minus 4 is going to become minus 4, 3. And the y-intercept is now going to be the x-intercept. Remember, smiley face parabola turns upside, it's like it falls over 90 degrees, but just check the turning point. It's always that very important part, because that's of course going to anchor it. Is this a function? No. Okay, but we're going to later restrict the domain. Next up, we've got the same parabola, but a is negative. So what's happening here? A is so you've got the turning point there, you've got the y-intercept, that's actually enough. So you know the turning point, 3 minus 4 is going to become 4 minus 4, 3, and then 0 minus 13 is going to become minus 13 and 3. So that was that one. There's the one reflected about the line y is equal to x. Okay, then we've got an exponential function, so 3 to the power of x here, right? And but I think it's always good, like I explained in another video. I have a couple of points about the origin, right? And you just you reflect those points about the line y is equal to x. Minus 1 and a third is going to become a third minus 1. 0, 1 is going to become 0, 1, 0, and 1, 3 is going to become 3, 1. So, and then of course that's that log graph where the base is going to be 3, right, x. If you reflect about the line y is equal to x. Lastly, we've got the graph y is equal to 3 to the power of x plus by 2. So that's the same graph, shifted 2 units up. So remember the previous one looked like that. This one is now just bumped up by 2. So the asymptote is no longer the x-axis, now it's the line y is equal to 2. So this is where I would start. You know the asymptote now is plus 2, right? So y is equal to 2 is going to become x is equal to 2. So your new asymptote of that inverse is going to be x is equal to 2. And then you just reflect those points about the line y is equal to x. Minus 1 and 2 and a third is going to become 2 and a third minus 1. 0, 3 is going to become 3, 0. 1, 5 is going to become 5, 1. And picture bang, bang, bang. There we go.